Now just imagine controlling any device in your home with just voice. This bulb here. Alexa, turn on bulb. Well, stick to the end and we shall figure it out how this thing works. Now what you are going to see is this schematic, which is the electrical diagram. So this is showing the peripherals, this is the main microcontroller, this is the relay section, this is the front panel, and that was the power supply there. And what we are seeing now is the PCB layout. This has been designed in Easy EDA software. So like this, we can design some certain electrical circuits and we can convert them to schematics. And now this is the 2D version of our PCB, which is the back side, and this one is the top side of the PCB. After designing, I gave it order to Robot.in for PCB manufacturing, and you can see it turned out really great. So it adds a really professional look to our projects. This is the front side for it. This is a 2-layer PCB. This is the back side for it. Now let's see what all different components we need for this project. The list is on the screen. As you can see, we need a variety of components. So this is the fast forwarded video. It shows how I am placing the components, and which includes the soldering also. We will start with the registers first. Now this is a fast forwarded video because it takes much time. So it took me around 1 hour to complete this soldering process. But the research which went into this project was too much, like literally. So let me just give you a quick overview of this system. So at the heart of this setup, that is the ESP32-C3. It is a compact and powerful microcontroller, both Wi-Fi and Bluetooth enabled capabilities. So it works directly with the optocouplers and a relay which controls the AC appliances on the other side. Now the real magic which comes from Sinric Pro, which bridges the ESP32 with voice assistants like Alexa or Google Assistant. It acts like an IoT backend, like a service which connects these two services together. So you register your device on their platform, and they handle the heavy lifting like the authentication, device control of the APIs, and syncing with smart home ecosystems. So whenever I give a voice command like Alexa turn on the fan, that command travels from the Alexa cloud to Sinric Pro servers. From there, it routed to my ESP32-C3 over the internet almost instantly. Like the ESP reads the command, identifies which output pins to activate, and triggers the connected relay accordingly. So now to make this work, the ESP32 runs a firmware. So for the time being, I am calling ESP32-C3 as ESP32 for a shorter name. So it runs a firmware using the Sinric Pro Arduino library. So that which handles the WebSocket connections, device pairing, and even handling in real time. Also, it manages the health and the OTA updates if there's updates any available, and if also sends an feedback update if the device status changes. So the voice assistant always stays in sync. So on the screen you can see this is the completed PCB. This is front side and this is the back side of it. Now this is our project which is finally completed. I have assembled back PCB and different panel PCB also, and there is this connector which is a aviation connector. It is a 5-pin connector which is used to quickly disconnect and connect this module. Like for example, if we want to do some repair work, or we will need to just disconnect and isolate this module from supply, we can just disconnect the connector. I have connected both the PCBs with jumper wires and used the wire guard to keep all of them in place. And also I have used heat shrink tubing. This contains high voltage, so now this is the boot up sequence of the device. First, after turning on, it connects to the Wi-Fi. after that it prints the IP address and MAC address of the device. On the display, the states of the devices are shown. Three devices are presently controlled with this: fan, tube light and bulb. If I turn this on, bulb turns on. If I click this, tube light turns on. So we have manual control plus the automated control. See, the switches are off. Alexa, turn on tube light. And on the display it is showing tube light on. Same for the bulb. Alexa, turn on bulb. Turned on the bulb. Lastly, for the fan, it is an infrared control. So for power it uses the relay, same as the switch. So, and for the infrared speed control, it uses infrared signals. This will emit signals. Alexa, turn on fan. Alexa, fan speed 2. So in this video we got to know about the DIY process and the working behind this hardware. So in the next video series, all the part remains is the software and the code. Like I'll be explaining the code, how it works and what goes behind the backend. Like the Sinric Pro uses the REST API. Now what is a REST API and all that will be explained in the next part. So stay tuned for that. Until then, keep exploring and keep experimenting.